Excellent, thank you. Well, welcome to our ctDNA Lunch and Learn webinar. So as you are no doubt aware, we've just commenced delivering this service for the Southeast region. I'm quite excited about it, and we've just got a couple of slides which should hopefully help you in delivering this service for your patients. So in this talk, Katya and myself will introduce the ctDNA service we're now providing you. We'll cover some basic background on what ctDNA is and the applicable national genomic test codes, the eligibility criteria for these, and what gene targets are covered. We'll go through the test ordering process, including sample collection, suitable tube types, completion of referral forms, and postage to us will be explained. And we'll also demonstrate our report template and explain what the relevant sections mean on these. And then there should be some time for questions and answers at the end. So just to introduce the team, so it's myself as service lead and Katya, and then we've also got Stuart as our technical service lead. The laboratory is open from 9 to 5, Monday to Friday, excluding public holidays, and we're currently located in Guy's Hospital. And email for lab queries, which we'll put up at the end as well, and our address for postage. And any queries on reports and analysis can be sent to our SCGLH somatic cancer email inbox. So firstly, I'll talk about some background on test directory targets and the role of genes that these play in disease pathogenicity and treatment. So I'm aware that many of you will already be aware of what ctDNA is and why we are testing, but just to provide a small bit of context for those of you who may be unfamiliar with the terminology or new to the area, circulating simply means that it is in the bloodstream, and free means that the DNA isn't encapsulated within cells, i.e. it's floating freely, which is one of the reasons why we need to process these samples rapidly. So circulating free DNA contains both normal DNA, shed during normal cell renewal, as well as tumor DNA. Circulating tumor DNA is a component of circulating free DNA that we are interested in. So M3.13, so M3 is the National Genomic Test Directory M code covering somatic testing and breast cancer. And within this, the specific test code M3.13 covers ctDNA testing for breast cancer patients meeting the eligibility criteria. So patients must have a diagnosis of ER-positive, HER2-negative breast cancer. So the genes required for testing under M3.13 are ESR1, PIK3CA, AKT1, and PTEN. So panel testing is for single nucleotide variants in all of these target genes, as well as copy number variants, in this case for PTEN. So why do we do this? Because variants in these genes listed are amongst the most common mechanisms for treatment resistance in ER-positive, HER2-negative breast cancer, and variants confer eligibility for targeted treatment. So an example of where ctDNA testing should be considered is for detection of mutations in ESR1. The ESR1 gene encodes the estrogen receptor alpha protein. It is a ligand-activated transcription factor activated by binding of estrogen and is responsible for upregulation of genes associated with cell growth and metabolism. So variants in this gene are rare in treatment-naive breast cancer, but are found in up to 65% of cases of treatment-resistant breast cancer. So the majority of the variants are found in the ligand binding domain and are responsible for dimerization activation in the absence of estrogen, leading to the protein being constitutively active or turned on. So ESMO recommendations are that this testing is performed using ctDNA and not tissue. And using ctDNA allows us to capture a more accurate snapshot of tumor heterogeneity in patients who are progressing and the detection of low-level ESR1 variants, which are often subclonal. There is a treatment for patients with activating variants in this gene, Electrosint, which is a selective estrogen receptor degrader. and it is approved for those patients with ER-positive HER2-negative breast cancer treated with endocrine therapy, including CDK4/6 inhibitors, who have disease progression and have undergone no more than one line of cytotoxic chemotherapy. So testing for non-small cell lung cancer is covered under M4, and the specific test code for ctDNA testing is M4.14. So patients should have a suspected stage 3-4 lung cancer, which is unsuitable for curative surgery or radical radiotherapy. Testing can also be requested for those patients with a new diagnosis of non-small cell lung cancer by histology, where molecular testing has failed and the only option for repeat testing would be additional biopsies. So the genes required for testing under M4.14 are largely the same as what you may have previously ordered under M4.1 and 4.2 testing for tissue samples. Oncogenic, likely oncogenic, or variants of uncertain significance will be reported in the key hotspot regions of EGFR, BRAF, KRAS, and ALK. The assay we use also provides DNA fusion detection. So in the next section, we'll talk about ctDNA sample collection and the test ordering process. We'll look at the blood collection kits, tube types, general phlebotomy guidelines, referral form completion, and packaging and dispatch. So the blood collection kits required will need to be ordered directly from Alpha Laboratories. And these kits will contain everything required for taking a blood sample suitable for ctDNA testing at your center. There are 2 glass tubes, absorbent pouches, a biohazard bag, and instructions for use sheet detailing how to take the blood samples, a box for return, and a prepaid address label. The kit does not contain a referral form, which must be printed off separately, filled in, and included in the box before postage to us. For this assay, the types of tubes we can accept are Streck cell-free DNA blood collection tubes. These tubes contain a preservative that reduces, but does not fully eliminate, the release of cellular genomic DNA during sample handling, shipping, and processing. It stabilizes up to 7 days at room temperature, but noting the caveat I've mentioned, sample quality will be reduced during this time. The longer samples are left in tubes without processing. It is also important to note that the preservative is only active at room temperature. Do not refrigerate these tubes. Also worth noting is the tubes are made of glass, so special consideration may need to be taken with regard to storage and handling. So some general guidelines for collecting blood samples in Streck tubes. So if multiple tubes are being collected, then Streck should be collected after purple top EDTA tubes. 2 tubes must be collected, and these need to be filled fully to the maximum volume. So low volumes can result in suboptimal or failed results. So after collection, tubes are to be mixed end over end for 10 times to ensure adequate mixing of preservative blood sample. Both tubes should be labeled with patient identifiers as on a referral form and must have a date the blood sample was taken. And just to reiterate, it's very important that tubes must never be stored or kept chilled or frozen at any stage. And this includes the storage of unused tubes after sampling or during transit. So next, I will briefly go through the layout of the referral form and the sections that need completing for testing. So the first section of the referral form to be completed will be the patient details, and minimum details to be included should include patient name, first and surname, patient date of birth, hospital number, and NHS number. It is also worth noting the text in red below, the demographics, advising that patients should be informed that somatic testing for ctDNA may identify secondary germline findings with potential risk for themselves and family members. Currently, we report likely pathogenic findings in the core ESMO genes and indicate a referral to clinical genetics where appropriate. So the next section will be where you indicate the referring clinician for the test is and where the report should be sent to. And underneath this is a section where the date the sample was taken must be indicated. Additional details on the patient's disease histology should also be completed where known, including current therapy. For patients being referred for M3.13 ctDNA breast cancer testing, you must indicate on the tick boxes whether the patient has ER-positive, HER2-negative breast cancer and that they have had progression after at least 12 months of endocrine and CDK4/6 inhibitors. Any previous chemotherapy and the number of treatments should also be indicated for these patients. So the clinical indication requires both the general M code, to be either breast or lung cancer, and the specific T or test code to be completed. So these will be either M3.13 for breast or M4.14 for lung cancer. Any previous testing should also be included on the referral, with the type of testing, i.e. whether it was tissue, ctDNA or germline testing, and the results, if known, should also be indicated on the referral. And if possible or more convenient, attach the referral form when sending. There is also additional space at the end of the form to record any pertinent, relevant information that could not be detailed above. So finally, for packaging and sending, so place the labeled and fully filled tubes in protective sleeves and into the biohazard bag. Place the bag and completed referral form into the box. Close and seal the box and attach the prepaid postage label to the box and send for dispatch by Royal Mail 24-hour. So what we need to receive to initiate testing will be a completed referral form with test code and date of sample, 2 fully filled 10 ml Streck tubes, which are labeled including the sample date, and these should be received within 7 days. So I'll hand over to Katia.
It will help if I unmute myself, I guess. I will tell you about the laboratory processing and analysis. But before we look at the workflow, I'd like to briefly introduce the actual test we perform in the lab, and that's the MSK Access powered by SOPHIA DDM. So this is a next generation sequencing panel, which covers CNVs in about 71 genes, SNVs in 147 genes, fusions, third promoter variants, and MET exon 14 skipping. This test also uses a ctDNA as well as a normal blood from the white extracted from the white blood cells, and that's a germline blood. Excuse me. So that's a high-level overview of the laboratory workflow. What we do in our lab, we take the plasma from the tubes that are sent and we extract the ctDNA, and then we extract a gDNA from the buffy coat. Both of those DNAs go through a quality assessment to ensure that they are good quality, and then we do a library preparation, next generation library prep for each one of them. Then we pull them together and sequence on Illumina NovaSeq, and then using the SOPHIA DDM platform, analyses are done, after which clinical scientist is looking at those analyses and makes the report. So why do we sequence both the normal and the tumor DNA? Well, when we sequence the plasma alone, we see everything that circulates in the blood, including germline variants and CHIP variants, CHIP mutations from the clonal hematopoiesis. And these are obviously not, and they can be actually misjudged as a variants coming from the tumor. So what we do, if we sequence only the blood, we see only germline variants. If we sequence only the tumor, we see the germline and we see the tumor-specific variants. and we don't know, and we might kind of give some, we cannot distinguish which one is which. So when we do both of them, we can distinguish very clearly which are the tumor variants only. So that's why we do sequence both of them. When we, this is the DDM, that's our analysis platform, and that is a landing page, which is how a sample will look. This page shows us some high-level quality metrics of the sample, of the sequencing for this specific sample, and some high level of the results. When we go to the variants tab, we can see different variances there. And if we look in a bit more details at this first two, we can see what we can see here is that each row is corresponding to a variant. In this case, the first one is corresponding to ESR1 variant, to a variant in the ESR1 gene. And what we can see here is the variant allele frequency coming from the ctDNA sequencing and from the germline. In this case, you can see that the ctDNA have a 9.61%, and then I'll say germline, but it's more genomic DNA, has not detected this variant at all. And it's the same for this other variant in the P10 gene, which also has been detected in the ctDNA, but not in the normal control. This means that this variant is specific for the tumor DNA, and it will be shown on the report. If we go back now and look at the other three variants on this page, what we will see is, for example, that's a variant in APC gene, and this variant is seen in 54% in the tumor DNA, in the ctDNA, and 47% in the normal control, which means that this is most likely a polymorphism, and it's also been marked as likely benign in here. More interestingly, these other two variants, which we can see at a very low level presented in the ctDNA, we can see them also present at the same low, as kind of similar low level in the normal control, which means that that's the ARID1A and the TSC1 is the same situation with this one. So this means that this is likely representing a CHIP variant. So we don't know what it is, but that's a likely explanation. So none of those, this is what, so that means that these three are not tumor specific, as they're seen in both, and they will not be on the report that you see. Talking about the report, let's move on and see how the report looks. I will start with a lung cancer report. So that's how it will look. It's about 3 pages long. Sometimes my camera is 4, and I'm really sorry about this. We're really trying to keep it down to 3. At the top of each page, you will see the demographics of the patient. And now I'll go through each one of the sections of the report, and we'll look in a bit more details. So if we go at this first bit, we see here there's the sample, the sample ID that's given from the referral form. On the second row, we'll see the clinical details, and this is the test code that James was just mentioning earlier. It will sit here, and there will be any clinical details given by the referrer will also be here. The next is the ctDNA fraction. So this is not assessed by our assay, but this is in development currently, and we would like, hopefully it's coming in the next few months. Why this is important and why we put it there? Well, that's because if the ctDNA fraction is low, that should be considered when you're interpreting the results, especially if there is a negative result. And on the other hand, if we have a high ctDNA fraction, that means that this supports a very clear interpretation of the findings that have been seen. Next thing you can see in here is this aged sample. So what this means, that we do recommend samples to be sent and arrived in the lab within 7 days. But if the sample, between the samples being taken and being processed in the lab, there is between 7 to 10 days, we've seen that there most likely will be some suboptimal results, so we need to flag those. And if the sample is older than 10 days, then we mark those as failed. As by the time they arrive in the lab, the degradation is so high that it's highly unlikely that testing at this point is unreliable. Next bit of the report will show you all the findings, and as well we'll kind of mention everything that was not found. If there were some genes that had a suboptimal result or they fail, they will be listed here. If there are no suboptimal and no fail, then there will be nothing in here. Any fusions will also be listed in here. Going back to the report and looking at the next section. So in this section you see the that's the actionability table, and this summarizes the clinical relevance of all the reported findings. Here we'll also put some what has not been reported, and any quality issues will also be highlighted here additionally. The second part of this section provides important reminder that the assay might have a false negative result, again going back to the ctDNA fraction, and it might be a false negative, and as well gives you a link to GTAP referral in case this is needed for this particular result, for this particular sample or patient. At the bottom, if we have additional testing done for this patient, we will refer those in here. And this might be anything else, an old ctDNA sample, or previous ctDNA sample rather, or any tissue that's been, those results will be here. Now let's move to the second page, where on the first bit, what we'll see is any additional findings. So anything that's not covered by the M code that James just showed earlier, we'll report here, and we will report everything that's tumor specific, it's pathogenic or it's oncogenic or likely oncogenic and being detected by the panel. It's very important here is to know that those findings will just be listed, but there will be no clinical interpretation. Should you need further clinical interpretation, we'll recommend to refer those to GTAP. The second bit of this is the regions of insufficient coverage. So on this report, this specific example, we have given that BRAF has been suboptimal and KRAS failed. And you can see all the regions that failed or been suboptimal. Very important thing to note here is that this quality assessment and coverage is done only for the genes covered by the test directory, and none of these additional findings, additional genes have been assessed for full coverage. And on the third page of the report, you will see some general information about the panel, what's covered by the panel. You will see also the code from the National Genomic Test Directory and what's covered and what is covered from there. And just very quickly, I'll go through another example of a breast cancer report, which looks very similar. It has the same sample, clinical details, fraction, and all the findings. In this case, there are no suboptimal or failed regions. You can see that nothing here is listed. There's the actionability statement and the GTAP referral and the reminder about the assay. The second page is the same. You will have the additional findings. Here we will as well report everything that we see that's additional, and it's oncogenic or likely oncogenic. An assessment of the regions of sufficient coverage. In this case, there were none, so this was listed here. And again, just a reminder, this one is only for the targets that are from the test directory. And at the back will be, again, the additional information about the M code and what's covered in here and which genes are covered, and about the some bits and pieces about the assay itself and what's covered in that. That's all the genes that are covered and regions that are covered in there. And that's how the report will look. And yeah, thank you very much. That's a kind of overview of the pathway. So it's ordering, lab processing, and then reporting. And I will end up here with the contact information for the lab. And here we've created a small feedback form. Please, everyone, do fill this one up, because we also wanted to invite you all to come to the lab, meet the team. And if you really want to do this, we will appreciate if you can do the feedback form, and there is some fields there if you want to come to the lab, or we can organize teams or anything else. It will be lovely to meet you and to talk about anything that's ctDNA related. Thank you very much. I think we are ready for questions.